water. About 3 feet of it falls as rain and snow in this part of New England every year. In cities and other developed areas, much of it runs off rapidly, down into catch basins and storm drains, where it races through pipes and discharges into our rivers. In forested areas, it's a different story. Over half the precipitation that falls in a forest eventually returns to the air through evaporation or transpiration by plants. The remainder percolates into the soil or flows across the surface of the landscape until it enters a stream. Hi, I'm Laurie Sanders. Just where rainwater flows depends on topography. With its hills and valleys, the earth is divided into distinct areas where all the water in that area will drain to a particular stream or river. This area is called that river's watershed. For instance, right here, I'm on a watershed divide. If I move just over here, pour out some water, it's going to flow west into the Housatonic River watershed, weaving its way through Berkshire towns, western Connecticut, and ultimately into Long Island Sound via the Housatonic River. However, if I walk over here, pour out water, this water will flow east into the Westfield River watershed, one of the large tributaries to the Connecticut River. Both routes to the sea travel about the same distance, but the pathways are quite different. When rain falls in an area like this, individual raindrops coalesce, trickling down twigs and bark to the ground. On the ground, these tiny rivulets merge with others, which collect in small streams, which join other streams. Ultimately, a great river forms. In the upper reaches of a forested watershed like this one, the stream temperatures are low, averaging just about 55 degrees Fahrenheit year-round. These relatively cool temperatures are due to the large amounts of groundwater seeping out of the banks. But it's also cool because these stretches are typically shaded with a dense overstory canopy. As the turbulent water tumbles and leaps past large cobbles and mossy boulders, it mixes with atmospheric oxygen. Since oxygen dissolves more easily in cold water, these waters become highly oxygenated. Fast, cold, and shaded. It's a combination that limits the growth of microscopic plankton, the tiny plants which are the base for most aquatic food chains. Instead of plankton, in this habitat, the nutrients come from dead plant material, leaves, twigs, bits of bark. This is the food for bacteria, fungi, insect larvae, and grazing snails. As the leaves and branches, silt, and sediments flow downstream, their journey is often obstructed by fallen trees and rocks. Riffles form where the river flows straight. In other places, pools are created, or beaches are deposited. Each is a distinct habitat, and each supports a different suite of aquatic creatures. In cold, oxygenated waters like these, you can nearly always find brook trout and the creatures trout like to feed on: stoneflies, mayflies, and caddisflies. Stoneflies like this one and mayflies have evolved streamlined, flattened bodies and specialized behaviors that help them avoid being flushed downstream. Other creatures have evolved different adaptations to avoid being washed away. Some burrow, others hide under rocks. Some actually attach to rocks using sticky saliva. Caddisflies form cases made of tiny sand grains which act like lead sinkers. Plus, the sand grain cases are camouflage and provide great protection from predators. As the river flows downstream, we can see a number of changes. The gradient is less steep and the current is much slower. The stream bed is covered with cobbles, gravels, and sand. Gone are the large mossy boulders. Plus, the river's wider here. It's no longer shaded by bordering trees. This shallow bedded stretch of the river tends to warm up during the day with a slight drop in temperature at night. With a slower current, more sunlight, and warmer temperatures, there's a big increase in the growth of algae, which in turn supports lots of microscopic one-celled organisms known as zooplankton. the base of the food chain is broadened, with a corresponding increase in the diversity of plants, snails, insects, and fish. In this section, just before it reaches the Connecticut River, our waterway is a deep, silt-bottom lowland river. This stretch is much warmer, and the water contains lots of silt, organic material, and nutrients like nitrogen and phosphorus from agricultural runoff and sewage treatment plants. The caddisflies, stoneflies, and trout we saw in the upper reaches are gone, replaced by creatures that tolerate low levels of oxygen and warmer temperatures, like bluegill, carp, catfish, midges, and aquatic worms. Here at the mouth of the river, we see a remarkable contrast to those upper reaches. The plants are different, the fish are different, the entire dynamics of the river have changed. In less than 30 miles, we've dropped over 2,000 feet, passed through some wild and scenic territory, through some of the best cold water trout fishing and kayaking in the state. The Westfield River watershed drains over 500 miles, yet it comprises less than 4% of the Connecticut River's total watershed. This means there are lots and lots of great places to explore. I hope I see you out here.
This program is made possible in part by a grant from the Silvio Oconti National Fish and Wildlife Refuge Challenge Cost Share Program and the Massachusetts Department of Environmental Management Greenways and Trails Demonstration Grant Program.